In this video session, we're going to organize and summarize quantitative data by using the dot plot and what's called the stem and leaf plot. The data that we are using is the student survey data from the early fall '09. Let's start with the dot plot. The way you construct a dot plot on StatCrunch is you go to Graphics, go down to where it says dot plot, pick a variable. We're going to do commute time, hit next. Here's some options. We could label the X or the Y axis. We can put a title. We can put grid lines. I'm going to keep it simple. Hit next, hit create graph. And we see this is our dot plot. Now we can stretch this out a little bit so we can see it a little bit better. Now what's nice about a dot plot as opposed to a histogram, dot plot keeps the raw data. So these are all actual raw data. They're not grouped in bins unlike a histogram. Okay, so if your data is discrete or you'd like to keep the raw data, a dot plot is a good way to summarize it. Okay, clearly we see some outliers here. Okay, let's look at another example. I'm going to go back and hit options and edit, hit back, and this time let's look at number of credits. Hit create graph, and very quickly StatCrunch produces the dot plot for number of credits. Okay, the next graph that we're going to look at is called the stem and leaf plot. We go to graphics, select stem and leaf. Let's look at number of credits. Hit next. StatCrunch automatically trims the outliers. We can, by default, it's on extreme only. We can choose none. We could go extreme only. Let's choose none. Hit create graph. It tells us the decimal point is one digit to the right of the what's called the stem. So these are your stems, and each of these are your leaves. So for example, the way we would read this is this would be a stem of 0 and a leaf of 3. So normally the leaf is 1/10 of what the stem is. So since this is number of credits, these are 3 credits. All these would be 6 students taking 6 credits, 7 credits, 8 credits, 9 credits, and then we jump up to a stem of 1. So that would be 10 minutes. So all these leaves here with a leaf of 0 would be 10 minutes, and then this leaf of 1 would be 11 minutes, 11 minutes. All these are 12 minutes, 13 minutes, 14 minutes. Then these would be 15, all these would be 16, 17, 18, 18, there were no 19, and then the last one's 20 credits. Now, I just want to show you how the stem and leaf may look different if we go back to options, we go to edit. Let's do extreme only for the outline trimming, hit create graph. Notice it's a little bit different. So if your data set has outliers in it, stem and leaf can change. So let's look at a more exaggerated example. If we do commute time, let's hit next. Okay, this time let's do extreme only. Let's hit create graph, and this time that we see we have somebody 3 minutes to get to Cincinnati State. These would be 5 minutes, 7 minutes, 8 minutes, one person 9 minutes. These would be 10 minutes, 12 minutes, so on and so forth. And then down here it tells us high are 80, 90, and 150. So those commute times are considered extreme. Okay. Now if we go back to options, edit, and this time we select no outlier trimming, hit create graph, it produces something very different. And notice it says the decimal point is 2 digits to the right. So what that would mean is this here, this 1 and this 5 would represent 150 minutes. So it depends upon the data set. Now what's nice about the stem and leaf and the dot plot is a lot of times it will, for most data sets, it will keep the raw data where the histogram actually groups them into bins, and when sometimes we lose some data doing that. Okay, so this concludes this video on organizing and summarizing quantitative data by using dot plots and stem and leaves.